we talked about the of 3D printing and what type of technology is out there. Since then, some of the technologies have changed, and some of the programs have changed, and I just thought I would share what's going on in our world, what we're seeing, and we'd like to hear what you all are seeing as well. So, just as a brief overview for those of you all that don't know who Stratasys is or may have not heard the name, currently we are the largest 3D printing manufacturer in the world. We hold hundreds of patents and have about 30 or 31 different types of printer technologies out there today. Those are some of the printers that range from what we call the desktop all the way to the production series type printers that are used in companies like General Electric, Boeing, Airbus, and some of even the smaller mom and pop shops throughout the country. So who in the world are we? Well, we were actually founded in 1988. A lot of people ask me that, you know, is 3D printing less than 10 years old? Well, no, it's actually older than that. We, Stratasys, were invented by our founder, Scott Crump, outside of Minneapolis in Eden Prairie, Minnesota. And about 3 years ago, we merged with one of our largest competitors called Objet, and they are based out of Rehovot, Israel, which is right outside of Tel Aviv. Combined, we have about 3,000 worldwide employees. I am responsible for the southern half of the United States concerning education. We are typically broken up into three major business segments. About 70% of our business comes out of the commercial world. About 25% comes out of the education, ranging from K-12 all the way up to post-secondary, and then the remaining 5% comes out of the dental market. We have roughly worldwide revenues of about $750 million, and that is strictly in 3D printing alone. I mentioned we have a number of grants, a number of patents, and those patents are growing daily. And roughly as of January, we have over 110,000 printers sold worldwide. So where in the world do we see, or what does the market say 3D printing's going in which direction? Well, if you look at the screen here, in 2013, they estimated around $3.1 billion. In 2020, in just 7 years, that number is going to grow 7 times to over $21 billion. So we, as a company, don't believe that we've actually scratched the surface with regards to printing technology, whether it be in home, whether it be in education, or whether it's in the commercial environment. And as people become more adept and become more willing to try 3D printing, we will continue to see this number grow. I'm sure you all have heard about metal printing. That is a new way of printing, and that's an area that we are aggressively pursuing, whether that be through acquisition or through a development of our own remains to be seen. But that 21 billion also incorporates even the metal printing technologies that are out there today. This kind of gives you an idea in for education and jobs. And you can see that when they started taking all of this data together, that, you know, July 2010, there wasn't really a whole lot of manufacturing or educational opportunities outside of in the 3D printing world. But as you can see, over the course of 4 years, the number of jobs is increasing every year, because as 3D printing becomes acknowledged and accepted part of society, there is going to be the need for technicians and engineers and designers that have the experience whether it's on a MakerBot to all the way to a Stratasys or a 3D Systems, or to an EOS or an RCAM metals printer. So we see education and jobs increasing as the need and the desire for 3D printing continues. When we look at education, for me, for our group, education is a way for us to shape the future. And we look at it through three ways: inspire, lead, and grow. Certainly, inspire is to recruit. We want to get students at a very young age. I've got a son who's 14 who thought that what I did initially was really kind of rocket science stuff. And then come to find out, when he started being able to draw in AutoCAD and connect dots and make things, he realized, you know what, this isn't really as challenging as we make it out to be. But what it did is it gave him a sense of, hey, I can create something rather quickly and develop something that, you know, that may be able to be used, whether it's through his peers or through his teachers or someone else. So, and then there's where we like to lead. We will continue to be on the leading edge. I will put out a little carrot that we will be announcing, whether it's at the end of this quarter or the first quarter, new printer technologies that will be coming out in 2016. I can't really discuss those now, but we will always continue to develop new platforms, to develop new materials, to develop new and exciting, faster ways of taking 3D printing to market. And then, of course, growing our market share is important to us because we are a publicly traded company. So we have to keep the mind of our shareholders and our employees and our customers that, you know, we are trying to do this for the common good of all of us, and we want to succeed as far down from the student level to the faculty level to the chief executive officer of General Motors or GE or someone like that. So we're always trying to grow our market share and our mind share and our name out there in the market today. For those that don't know the different types of technologies that we get into, I'm just going to briefly go over a couple of them. Number one is FDM technology, and FDM is actually liquefying a thermoplastic, and whether it's ABS, nylon, Ultem, or polycarbonate, and laying down a layer of plastic at anywhere from 5 thousandths to 13 thousandths of an inch and building the part up. The unique things about FDM technology is its high strength, durability, it's low cost in comparison to some of the other technologies out there, and its accuracy. So we can create the same part over and over and over again in repeatability and accuracy. And the major reason we do that and are able to do that is because of one of the patents that we hold, and that is the heated build chamber that allows us to keep a constant temperature within the chamber and not just the bed. So we eliminate issues of curling or having parts that may come off the tray, unforeseen issues. So this is one of our technologies, and this is actually the one technology that was invented by Scott Crump, was the FDM technology. The other technology is PolyJet, and PolyJet is in essence a photopolymer, an inkjet if you will, that lays tiny droplets of materials through a various number of heads on the printer, and then you're building the part up, and a UV light cures the material to give it a harder feel. The nice thing about the PolyJet is that it can print down to 16 microns. So if somebody has something that is in need of a fine finish or very smooth finish or realism, PolyJet is typically the way to go. This year in 2015, we came out with the very first full color printer, which could print over 1,000 colors and even incorporate what we call digital materials or rubber-like materials in a single print. So an example would be, and if you ever see us at a show, we have these, is actually a human heart, and it has been 3D printed, and it's got a soft feel to it, so we can change the Shore value of that heart. And then the ventricles are printed in a rubber-like material, again in a single print, to give it some flexibility, almost like the veins in our body would be. So we're able to print in digital materials, and then we also can print opaque to clear, so you can actually look inside that heart and see the different chambers, as well as we have bloodlines running through it. So it's very impressive way of printing, and we find that that type of technology is used in most of the research universities and some of the universities that are dealing in the medical side. So Stratasys in education, what does all this mean? Well, when you look at education, we have now taken on a different mindset on how we're going to go to market in the educational side. We recently came out with a curriculum, and we are going to be tweaking and modifying and updating and potentially changing curriculum for the different levels of education. You can't certainly use the education that we've written for someone in post-secondary in K through 12 because they may not understand or don't understand the nuances of what it is we're trying to achieve. But we're developing a framework which will allow the individual to learn, whether it's introduction to design, to dimensioning, to design process, conceptual processes, things of that nature. And then also incorporate projects, whether it's through one of the different types of programs, architecture, engineering, gaming. Gaming is very popular these days, especially with young adults and teenagers. They want to come up with a really cool figure, if you will, so that's something that's really very important to us. And then we have to determine the duration. Do we only have a snippet of time to come up with a project, or would this be something that would allow us to cultivate or to embed into a full trimester or semester? And so we're trying to come up with different programs that will allow us to kind of be able to be used in all different types of school settings. And then, of course, the experience level is very, very important to us, because we know some students come in with a little bit of experience, i.e. my son versus somebody else who may not have been exposed to 3D printing or any type of CAD drawing. So we have to be able to come up with programs that really hit the different experience level, and that's where we're coming in with, again, beginner, intermediate, or advanced. And mind you, this is strictly geared right now towards the middle and the high schools. What we're doing for post-secondary is a little different, and we'll also get into that here in just a moment. So, example. So when we talk about design a toolkit, so we'll kind of go through the different types of programs, whether it's through orthographic projection, design processing, development, formalization, and then you can see on the right-hand side the different type of projects. So it's a product design. The duration may be 2 to 3 weeks, but this level you would find as an advanced level. And specifically, you would probably find the advanced level more in the junior, senior level grade. And that would be something where you'd have 11th to 12th graders who have already worked their way up through basic design, basic CAD functions, things of that nature, and they're able to design a 3D print chess piece, and I'll show that to you in just a moment. What we are getting ready to implement is, and what we have implemented was our first attempt at university curriculum. And that was, the first was released, I believe it was in January. We are currently uploading and updating some of that material because we've had some good feedback from universities as well as community colleges who said, know what, this hits the mark, but this doesn't hit the mark, and this is why it doesn't hit the mark. So we've been able to go back and update, upload, modify, change things that have really needed to be updated, and we hope to hear from some of the other universities out there and the colleges out there that take the time to go through this to tell us the good, bad, and the ugly. Fortunately, we've had it downloaded over 1,000 times in almost a year. It is still free. This material is still free, so if you do go to the stratasys.com website, you may have to go to the search engine and type in curriculum, but it will take you to the link where you can actually download the materials at any time. And this type of material is being currently taught at the University of Minnesota as well as some other international universities. Then to the colleges and the universities, you know, our mainstay has always been in manufacturing and engineering. Art and animation and architecture have become growing areas of areas in 3D printing for us, as well as design. And when you look at some things like this, this is the car that the folks at Southern Polytechnic State University in Georgia make. And that manifold was an area that they had some major issues with trying to come up with a high temperature, lighter material so the car could go faster. And the material that we proposed to them was Ultem, which is a high temperature material. So now they have a lighter manifold that allows the heat not to destroy the part, and also allows them to go a little bit faster because of a lighter design. So again, what they were able to do is take some of that curriculum, take some of that design, take some of that information, and then come back with a design where we helped them print this part, because for us it's advantageous for the colleges and universities to show what they do and how they do it, because it becomes a win-win-win for all sides. This is another picture of another part that was printed for Southern Poly as well. And then these are some of the students at Southern Poly, and you can see that they've got a couple of our, what we call our desktop printers sitting there. Those are our U-prints, and they are probably our most popular printers in education and workcourses. And then here's an airplane that was built as well. And all of those components, for the most part, of course, certainly not the copper, but most of these components were built within that Fortis 400 printer, because again, you can print the ABS, you can print polycarbonate, Ultem, nylon type materials in that same printer. You can't print all of those materials at the same time, but you do have the ability to replace materials, change tips, and print the parts that you do need for and with the necessary materials that you need to achieve the part that you're trying to create. And then medical. I think it's really important that as we move forward, that a lot of us are seeing today news that states that they're trying to come up with ways of printing cells and live cells and organisms for the inside portion of a human body. We're not there. That's actually being done mostly by research universities who are taking a 3D printer, whether it's a Stratasys or whether it's somebody else's, and trying to develop the type of materials that will allow them the ability to print live cells with other base materials that can be used inside the human body. We are just an avenue, if you will. We are providing the equipment, and sometimes we're providing the some base materials to some of these universities. And the issue that they will run into, like everybody else will, is that the FDA approval is long and arduous and time-consuming. But once this actually does get approved, this could be a major game changer for whether it's the outside prosthetics to the inside portion of the human body, and how we go to helping heal somebody from a major injury. And then when I talk about prosthetics, this is a program, I don't know if anyone has ever seen the video, but this little guy here has been the, oops, sorry about that, has been the essence of trying to get the prosthetics market out there today. And this is actually a program that was worked with the University of Central Florida, where they actually came up with an arm, what is it, the X-Man arm, or I'm sorry, Robert Downey Jr. Iron Man, the Iron Man arm. And if you ever get a chance, I think it's out on YouTube, where you can see him actually meet Robert Downey Jr. for the first time, and they share their stories and they share their hands. Robert's got his, and this little guy's got his, and it's really an interesting story. But prosthetics and outside the body materials and designs are very, very popular, and will continue to be for quite some time. I'm not gonna waste your all's time watching a video, but if you ever get a chance, go see this video at the University of Virginia. They're doing some really fascinating things. Them, along with MIT, are really taking 3D printing to the next level. And I would really kind of challenge you guys and to watch the video and give me your feedback. Let me know what you all think about it, because I think this is the direction that we're all headed in. So if you get a chance, take a look at it. What's next on the horizon for Stratasys? Well, it may not be as needed in a 4-year university, but certification. Certification is an area that is becoming more and more spoken, and the desire is there for having some type of certification around advanced manufacturing. And we have developed with Dunwoody College an advanced manufacturing certificate, but we are also trying to figure out how does this really mean much to the student when they go through the curriculum. What is it that they're going to achieve? So we are working with companies like MSSC, NIMS, NAM, NISOD, all of them, about how do we come up with a certificate that will actually have some type of meat or credence to it when the students leave here. So we will become introducing, hopefully sometime in early 2016, a new certification that will allow them to take this to their employer and say, hey, look, I am certified on 3D printing, advanced manufacturing, rapid prototyping, whatever the buzzword is today, and here are the different areas that I'm proficient in, and allows them the opportunity to get a job if they choose not to get a four-year diploma. So we're working urgently to get the certificate done, and when that is done, we're hoping that the next time we do this, we'll be able to show one to you. We always like to show student projects. This is, again, an area that just allows us to really kind of show off what you all as students do. I can sit here and talk about Stratasys till we're blue in the face, but I really like to show what students go out of their way to do and develop. And this is just kind of like a metals foundry, if you will. So this just shows you the different types of 3D printing processes and foundry work and finishing that students will actually take to develop parts. Robotics. Robotics is another big area for us. We have a nice partnership, if you will. It's a kind of a unspoken or undocumented relationship with our friends at FANUC, where we are doing end-of-arm tooling. So we can help develop different types of tooling or grippers or suction cups or things of that nature. And then Zeiss. Different types of gauges, go, no-go gauges, jigs and fixtures. And again, these are things that students are creating and employees are creating. These are not things that we as employees of Stratasys are creating. These are things that students are creating. Black & Decker. For those of you, I'm sure most people have heard of Black & Decker and the Weed Whacker. So this is just the automatic feed spool. And what we have found with this particular part is that it has actually held up better to the original molded part that is currently on the Black & Decker weed trimmer now. So they're trying to figure a way how can they incorporate this as a production part. And you know, what's really cool about this is that students, I don't know about this particular one, but I can tell you at the University of Louisville, students who are developing stuff for companies like General Electric, or the student who may be developing the part here for Black & Decker, you know, they may turn this over to Black & Decker and they may get the patent on it. The company may get the patent on it. But what's unique about that is that the student then will get royalties from that particular part, and that's really fascinating, and that's really rewarding to see. What, you know, the basics that we're bringing is just the 3D printing and the material, but the mindset and the development and the cognitive behaviors of developing really fascinating in-use components that we can sit there and point to and say, you know what, I know the story behind that particular part, or I know why that part was made, and a junior in college created that, or whatever the case may be. So it's really neat to be able to see the different types of projects that students are coming up with, and we're hoping that this continues. We're hoping that it will always continue, because we don't feel like we've actually scratched the surface with it yet. Certainly in elementary, Starbase. Starbase is big with Stratasys. We implement a lot of time, effort, and resources in the development of Starbase and their national program teaching, and actually STEM or STEAM. So we are very active in what we do with kids, and again, we try to capture them at a young age. You know, with our sister company MakerBot, we see a number of smaller MakerBot, what we call hobbyist type printers in elementary schools, and we also participate in some of those with our Mojos and our U-Prints, especially those schools that are printing higher end. And then in the middle schools and the high schools, where we're beginning to see more fab labs or robotics and actual virtual present types machines. And I just figured what I would do is I would just kind of show a few, a couple more different types of examples. This was actually made in a middle school. Cups, ill-filled cup holder. So this student actually developed a solution for a problem and came up with a new design. Again, I mean, I could beat a dead horse, but again, it's just the different types of components and the different types of projects that have come out over the course of time through different students. This is a view of the University of Minnesota, and I'm not going to spend a great deal of time on this, but I will tell you that if you look today at a 3D printed person versus the real person, I would challenge you that for most of us we would have a hard time determining what is real and what is 3D printed, just from the mere fact that 3D printing has really come way down the line on how accurate things can be. The nice thing about the University of Minnesota is that the individual that has worked on this particular project has found that the quote-unquote dummies that they use, or the different types of components that they're teaching with, yes, they may be lifelike, but no, they don't really speak the whole story of what it is they're trying to achieve. And what they were able to do is technically 3D print human bodies and human parts that will actually emulate the human body. And they've been able to increase their students' awareness, increase their students' understanding, and increase their students' overall understanding and grades in fully 3D printing parts and different human components that are more lifelike than what they see in a dummy or just a simple part. So again, the simulation portion behind this is very, very important and has been very, very keen for the University of Minnesota, as well as some of the other four-year universities throughout the country. Now, this is probably one of the coolest things I've seen in a long time. We had a student that won a project where they actually started 3D printing a full chess set, and these are some of the different types of samples that were printed. And I just think it's really kind of neat that you know, they're cultivating their own, putting their own little spin on the different types of chess pieces and implementing different types of materials. So again, this is just some of the examples of some of the chess pieces that were entered into this program. And finally, we talked briefly about the material, the curriculum, and I made a mistake here. Oops. Yes, it was. I'm sorry. It was just introduced in December of 2014. I should have said modified December 2015. But again, this is stuff that we feel is going to be. It's nice to have the 3D printer, but it's also really important to have the education and the curriculum and the tools to help train. If you give them that type, we don't expect the teachers to be 3D printing experts right out of school. But we do expect that if we're going to develop the printers, that we need to be able to arm the teachers and the professors with information. And that's where we've developed this type of project-based learning, so it can promote the students and promote their abilities and their participation in 3D printing. Oh, sorry, it's a duplicate. Why are we investing in education? Every student really deserves hands-on experience with 3D printing. It's one thing to have a really cool piece of equipment, but just having one cool piece of equipment to print Iron Man figures or chess set pieces is one thing. But we know that based on the information that I showed earlier, that there are going to be jobs out there that are going to be calling for additive manufacturing technicians, 3D printing engineers. If you go look at Career Builder, you can probably type in SolidWorks, and you will find a listing of all of the job opportunities that exist today for someone who understands SolidWorks. If you type in 3D printer, you're probably not going to find maybe 1, 2, maybe up to 5. But we know that as this continues to grow, and as this continues to become a mainstay in manufacturing, that students and future employees need to have the education and the hands-on experience, so when they do apply for that position, and they may either have the 4-year degree or their certificate, that they can go to their employer and say, I am educated in advanced manufacturing or 3D printing or whatever those buzzwords are today. So it's very important that we stay on the forefront and we continue to develop new and exciting printers. Yes, we will get into the metal printers. That will be something that will always, right now, is kind of behind the man behind the curtain is developing, or do we do the acquisition. But that is also something that is relatively new for us, and so we're trying to figure out how do we play in that arena, what are we going to do in that arena, and but we also feel that we haven't really scratched the surface, so to speak, with regards to the 3D printing that we have and the technologies that we have today. So, in summary, we will always continue to invest in our students. And when we say in our students, because we feel that if a university or a K-12 or a community colleges have invested in Stratasys, then we want them to be the best that they can possibly be. So we will always continue to invest, whether it's into those individual schools or the individual students. We will continue to develop content for K-12 through the post-secondary. We will always continue to listen closely to those instructors who want us to do more to become better for them. We will always continue to link the education and the industry, because those two areas, as long as they're communicating well with each other, and the education, if the industry is teaching what the education needs them to, then we feel that it's a win-win-win for everybody. So we will continue to do what it is that we need to do to invest in this model. So at that point, any questions, comments?
Yeah, I'd like to open up the floor to any of the students in the room that would like to ask questions about 3D printing or anything in general, maybe about jobs or the future of 3D printing. I guess I'll start. Terry, what is the most, where's the trend going with 3D printing as far as other industries? I've seen things where people can go up to a vending machine and order an Oreo through a 3D printer that's edible, and they can design their own Oreo for like $1 or $2 and eat it right there on the spot. I've seen the fashion industry developing clothes as well.
Mm-hmm.
Where do you see 3D printing going in the future as far as other?
We see it to be endless. We certainly think that we're going to see 3D printing in people's homes. You know, we really haven't caught on to the food printing per se yet, but we do see that fashion and jewelry and shoes and things of that nature are becoming more of a mainstay. So we're still of the mindset. Now, our mindset has kind of dropped back a little bit. We thought that by 2020 everybody would have a 3D printer in their home. Well, we're kind of tweaking that a little bit, but we believe that over time that this Star Wars or Star Trek type technology will actually be in everybody's home, and that it will be something that people use on a routine basis.
Does anyone have any questions for Terry about 3D printing in general?
Yeah, I have a question.
Yeah, go ahead.
Does Stratasys have any plans to enter the laser sintering space in the future?
Yes. Yes. As I mentioned before, we will either A, do it by acquisition, or B, we will do it as a development of our own. And just the little bit that I know or can share is that we will have a hard time reinventing the wheel, and knowing that we have some, I don't say deep pockets, but we have some deep pockets. We'll probably end up acquiring somebody. That's the fastest way to get to market is through acquisition, so we'll probably end up acquiring somebody.
All right, thank you.
Mm-hmm.
Any other questions for Terry? No? Just curious, anybody thinking about going into this field? I know we have some people in the Microsoft Office class, but can you see yourself going into 3D printing? Or, here's a question I bring, Terry. What is the average consumer cost for a 3D printer today?
The average consumer cost can start anywhere from as low as like $300 for a very, very simple printer to some of the, the maker bots can get you up to $2,500. What we've historically found is that for the 10 or 12 that come in 1 year, 10 or 12 will fall out just due to economics. So on the low end, you can certainly find some of the folks out there that are making $300 printers. Now, is it going to be something where you can make a production part? Probably not. But it is typically a good starting point for someone to make and develop something, but it may not be the exact same thing that our printers can do.
Okay. And I guess my last question, I have one more question. Do you want any questions? All right. What's the average salary that you see for someone coming out of a 2-year school, for someone that does SolidWorks or trying to be a 3D engineer for printing? Just on average, if you have any.
What is the average what?
Salary.
The average salary. Wow. Okay. I can only speak of what I know, but just to kind of give you an idea, since I live in Louisville, I do know definitively that there are 2 speed students from the University of Louisville that just got hired by GE, and their starting salary was in the mid-60s.
All right.
So it's not inexpensive. I mean, you can make a very comfortable living, especially someone who's in their early 20s, mid-20s. First job, starting out making in the mid-60s is not bad at all.
Especially for only 2 years of school, right? Or is that 4 years?
University of Louisville is a 4-year school, but I would hesitate to say that probably anywhere from 40 up for just having a 2-year diploma.
Okay, great. All right, can we give Terry a round of applause? Terry, is it possible to get a copy of that PowerPoint where we can distribute to the students?
Absolutely. I will send it over to Jerry.
Okay, and we're actually recording this session too, so if anybody wants to look at this later for future reference, you can do that too. Okay. And so I guess that's it. Terry, thank you so much, and have a great day.
Thank you, you too.
Okay, we'll talk to you soon.
Bye-bye.
Bye-bye.
All right, bye-bye.
All right, thanks, Jared.
Hey, anytime. No problem, yeah.
All right, guys, let's head back over and talk about Excel.